Okay, next question that we got on the menu here. How do we graph the parabola x equals y squared minus 4y plus 3? Now, this is a little bit this can be intimidating at first, but it really isn't. Because if you look closely, this follows the parabola format, and we're just not used to seeing like y squared. We're typically expecting to see x squared and stuff like that. But that is no worry. We can still handle this. Now let's see if we can factor out, or if we can factor the right side of the equation to see where our y-intercepts are. Okay, so now we're pretty much looking for something that multiplies to 3. Or we're looking for a pair of numbers that multiplies to 3 and adds up to a negative 4. So 3 is a prime number. So we know that there are really only two possibilities, since this is positive 3, that we can be adding stuff, that we can be multiplying stuff together to get positive 3. So we either have 3 and 1, or we have negative 3 times negative 1. Because those will both give positive 3 here. And added together, they have to be negative 4. Well, those added together are positive 4. So yeah, they're disqualified. See you later, alligators. Adds up to negative 4. It's got to be negative 3 and negative 1. So those are going to be the terms that when we have a factored out version, we have y minus 3, y minus 1. Does that make sense? Let's try to multiply this out. We get y times y squared. And we get negative 3y and negative 1y together. That makes negative 4y. Hey, that looks good. And then our last term is multiplied together. Negative 3 times negative 1. That's positive 3. Huh. It's almost like this always works. Ain't that beautiful? Okay, so now that our equation looks like this, we can more easily find our y-intercepts. So we want to see, when does x equal 0? X equals 0 when either one of these terms is equal to 0. So either when this whole term is equal to 0, or this whole term is equal to 0. When either one of those is equal to 0, x will be equal to 0, because it will zero the entire right side of the equation. So x equals 0 when y equals 3, and when y equals 1. Okay? So that's cool. Y equals 3, y equals 1. Like when y equals 3, 3 minus 3 is 0 times negative 2. Or I mean 0 times 2, that's 0. And then when y is equal to 1, this term becomes 0. And that term becomes 0, and this whole thing is 0. Okay, so these are a couple points of interest. This gives us 2 points of interest. We got x is equal to 0, y is equal to 3, as well as x is equal to 0, x equal to 0, y equal to 1. Those are 2 points of interest. And we're also going to want to find, we know that, hey, these are our 2 x-intercepts. Or not our x-intercepts. These are our 2 y-intercepts. We know that the highest point, because like, okay, so this is basically going to be a parabola, but it's like horizontally shaped. They actually have a graph of it in the answer. We know that if we have 2 x-intercepts, or 2 intercepts in a parabola, 2 roots, these are the roots. Roots, like the sweatpants, but no, we're not going to sweat it. We got our smarty pants on. We got 2 points of interest. Those are our roots. We know that the peak, basically like the tip of the parabola or the bottom of the cup of the parabola, is going to be exactly halfway in between them. So when y is equal to 2, because halfway between 3 and 1, you know, what's in between 3 and 1? Exactly halfway. It's got to be the number 2. Y equals 2. That's going to be the peak value. So let's see that what x is when y is equal to 2. So we'll have 2 minus 3. Multiply that by 2 minus 1. Some quick math. 2 minus 3, negative 1. Quick math. 2 minus 1, that's 1. X is equal to negative 1. So that's another point of interest. This is like the peak, sometimes also known as the critical point. But that's more like when you get into calculus that you'll learn about that. So what's there? The peak or the critical point is going to be when x is equal to negative 1 and y is equal to 2. Okay, these are the most important points of interest when you're drawing a parabola. Is the roots or the intercepts. Is these. Sometimes you won't even have roots, and that is a possibility. You'll use quadratic formula to figure that out. And the critical point, where that parabola turns, there always has to be 1. This is going to be the tip of the parabola if it's hill shaped, or it's going to be the base of the valley if it's like cup shaped. So draw in these points of interest, and you can really like connect the dots. Like, of course, you can get as much precision as you want by, you know, finding different x values or subbing in different y values, finding out the x and calculating it like that. But once you draw these 3 points of interest, you can pretty much connect the dots, and it's not that important. Like, you want to generally follow the pattern, but if you're drawing this by hand, these are the main points of interest that you just want to connect them, and everything else should be good. Sounds good. Now this solution, it looks right. So we do have our points like x equals 0, y equals 1, x equals 0, y equals 3, and x equals negative 1. We got 2. Those are our points of interest. They appear on the graph that they gave, so that's good. I just think this explanation is could use more explanation. So more explanation on how this could be done by hand. Yep, so once you got the points of interest, connect the dots, and that should be pretty good. Okay, awesome.